last class, we talked about the architecture of a computer. We said that a computer has its own memory, and memory is also of two types: short-term memory and long-term memory. What we refer is as RAM, random access memory, and we also say hard disk, where you permanently store all your data on your computer, right? Because RAM is very volatile. So you shut down the computer, RAM is gone. If you want to save it on the hard disk. And that is why when you close a file or you have not saved your changes, it is the program, your Microsoft Word is running in the RAM, and it is asking, should I transfer the data to hard disk? When you click save, that is what it does. Okay. In the RAM, then you have what we call it a processor. Every computer has a processor that processes your data, does your computation. Memory is for storing, processor for executing. This is for execution. This executes your code, this stores your data. Okay, and then it gives you an output, and you give your input here. And this is two-way. There is a reason why I drew here two-way processing, if you notice here, because when you execute things, you store in memory, you again get it from memory, you do something, go back. It continuously, memory and processor are best friends, they work together. The job of processor is to execute it, the job of memory is to store it. And I'll give an example of how really it works behind the scene. The rest all relatively input and output is easy. But I want you guys to understand what happens in the memory. First thing you should know is that the unit of measurement of memory is in byte, right? Byte is 1 byte is when you say letter A, it takes 1 byte. Letter B, it takes 1 byte. If I write my name Yash, it is 4 byte. 1, 2, 3, and 4. It is 4 byte of data. So when you say 1 megabyte, 1 gigabyte, is basically you're talking about how many bytes it can store either on your RAM or your hard disk, in terms of memory. So when you say 4 gigabyte of RAM, 4 GB RAM, you're talking about 4 gigabyte of data you can store. 4 gigabyte letters you can store in your RAM. That is what it really means. It's basically the capacity. Okay. Now, important thing is what really goes in memory. Let me write a basic program. Say I'm saying that there is a number called A and A is 5. There's a number called B and B is 10. And I want to calculate C, which is going to be A plus B. And we all know that C will be 15, right? But when these 3 lines of code, when you write it, and I'll show you also what really happens. So suppose you wrote this program in Python and you give it to processor, it converted into machine language by Python, compiler, and now processor is running it. Okay, in the machine language code, it's already converted into machine language code. Processor is going to run it. First thing it will check is A equal to 5. So basically there is no operation here. You're not adding, you're not subtracting, you're not doing it. You're just saying that I want to store 5 into A. So processor, when it sees this statement, it sends it to memory. Okay, let me draw memory in blue. This is your memory. And think of memory as a hotel. Okay, so when I say hotel, what I mean is that you are basically, think of this, your family is going on a vacation. Remember your last vacation you went. What you really did is your dad or your mom made a reservation in the hotel, right? And you say, hey, it's a party of 4 and we are looking for an studio, or you're looking for a 2-bedroom, suite. Based on the size, right? The hotel manager made some reservation and he says, okay, my hotel has 32 rooms, right? I'm just showing you some room. I drew different sizes of rectangles, right? Or squares. And that's intentional because I want to show you maybe this is a executive suite. right? With windows view to the ocean and all that part. And this is your like maybe two bedroom. This is your one bedroom. This is maybe your studio. This is your two bedroom. A hotel has different type of rooms, right? To accommodate different type of customers. If you're on a business trip by yourself, maybe you'll take a studio. That's all you want. Now, if you're going to stay there for 7 days, maybe you want a room with kitchen, or maybe 15 days. And hotel usually has different type of rooms and arrangements. So what happens is when you say a equal to 5, so before I go there, so you make a reservation, you go and stay in the hotel, your vacation is over, and you check out. What really happens after checkout? The cleaning service comes and cleans the room and makes the room ready for next customer. That's how hotel operation runs, and efficiently allocates its business, manages the rooms, allocates rooms for its guests, and gives good experience. Memory works in very similar fashion. When you run a code and say a equal to 5, you are basically, processor doesn't have to do any computation. There is no addition, there is no subtraction of numbers and all that part. So in the first line, all you're doing is, hey, I need to create a room called A, and 5 is going to live. You're making a reservation. You're declaring it a room, and you're assigning a guest in that room. So A is nothing but a room here. And let me use black right here. So room A, and guest 5 is going to live inside. You go to the next statement, and you say B equal to 10. You say another here, and say 10 is going to live, and this room is going to be called B. So B is the variable B, and I'll talk more about variables in the next class. The B is nothing but a room number in which a guest called 10 lives. So interestingly, what happens is A equal to 5, as you can see, you are writing to the memory. You're assigning a value to the memory. This assignment, A equal to 5, is you're writing to the memory. B equal to 10, you're writing to the memory. You can see. Now what happens in the line C? Pay attention, because this is interesting. Remember, Python executes from top to bottom, and it executes the right part, it computes, and then assigns back to the left side. Now, in order to calculate A plus B, on the line number, this is third line, this is second line, and this is first line. Line number third, the processor completely forgot who is A and B, because it does not know. It fires and forgets. So A and B, Python processor does not know. The computer processor does not know. So it is going to check from memory, hey, who is A? And memory will go and check that, oh, A is a room in which 5 lives. So it will send you back 5. So for this, it is 5. Now, basically, what you're doing is, when you say on the right side, all these A plus B, you're reading the value from memory, because processor is asking memory, who is A? I don't remember. Similarly, it asks, who is B? And memory says B. Oh, okay, let me check. It's 10. And it's 10. So it says 5 plus 10. Now processor can compute these two values, because it's an addition operation. It will say 15. And then actually this becomes C equal to 15. And then again, this is an assignment. It goes and gives to memory that, hey, store 15 in C. So it goes and creates a room, it puts a level C, and this room is actually 15. Now again, if you say C equal to 20, after this statement, processor is going to send 20 to room number C. So see, this time 15 is kicked out, room is ready for next guest, and new value is 20. If you now say, I want to read value of C, it will give you 20, not 15, because 15 is gone. 15 was in this statement. After then, we moved a new guest inside. Is this part clear? Okay. So this is how the memory is managed. When you declare a variable, when you create an assignment, when you write a code, this is what happens behind the scene in the memory. The memory remembers things. It gives value back to processor. It receives value and stores in it in the hotel, right? Processor does not remember anything. Processor job is to live in the moment. Okay, it lives on the line number 3. It completely forgets about line 1 and line 2. Processor always lives in the moment on the line of code it is executing right now. The job to remember lies with memory. So as you can now understand, in a computer architecture, one component does one thing and does it nicely. It doesn't try to do so many things. So memory's job is to remember. Memory's job is not to process the information. Processor job is to process the information. Okay. With that, I think I have covered this basic. In the next class, we'll talk more about variables. We'll talk about assignments. We talk about writing some basic program and all of that part.